Okay, so I selected portions of the textbook to go over what I think you need to know from section 3.2. And section 3.2 is all about logs. So it starts by telling you what the definition of a log is, and essentially it's the inverse of an exponential function. So if you have an expression or an equation such as log, you'd read it like this: log base b of x is equal to y. In this particular example here, oops, okay, in this particular, sorry. In this particular example, I selected log base 8 of 512. So what that means is that 8, if you were to rewrite it in exponent form, you'd say 8 to what power equals 512. Okay, that's what that means. So if you look exponential form of your example here, the box that I gave you, you have b to the, over here you have b to the y power is equal to x. This is the exponential form of log base b of x equals y. Okay, so that's the general idea. So in the example here that I gave you, log base 8 of 512 would be 8 to what power is 512? And you should know that 8 to the third power is 512. So the answer would simply be 3. Okay, so the answer here should be 3. Log base 8 of 512 is 3. Okay, or and the way to figure that out is by asking yourself 8 to what power would give you 512. So if you move on to the second example that I have, you have here log base 2 of 1 over 32. Okay, so essentially I would be asking myself 2 to what power would give me 1 over 32. Now I know that 2 to the 5th power is 32. But if I want 1 over 32, that means that it would have to be a negative number. So I know that 2 to the negative 5 power would be 1 over 32, which means that log base 2 of 1 over 32 should be negative 5. That's what your answer is going to look like. Okay? So here you have some sorry. Still learning how to operate this. So over here, you see some basic properties of logs. So for any number greater than 0, and of course the number has to be greater than 0 because that's just what the domain of log functions are going to be. They are always going to have to be positive. If b is not 1 and x is a real number, then the following are true. So any positive number to the 0, or actually any actually can be negative too. Any number other than Actually, for positives, of course, the domain, I'm sorry. So for any number greater than 0 to the 0 power, the answer will always be 1. You already know that, right? Any number to the 0 power is 1. Any number to the 0 power is 1. If you have log base b of b, essentially those cancel out, and it would be 1. If you have log base b of b to the x power, this would cancel out, which means your answer would be just x. And the same applies for b to the power of log base b of x. So those would also cancel out. All right? So if you're looking at some examples, in this case, you have 12 to the power log base 12 of 4.7. You need to know that this would cancel out, and your answer would just simply be 4.7. Okay? You need to know what a common log is. And a common log is a logarithm that has a base 10. Log base 10 is called a common log. Okay? And what you need to remember is for common logs, you are not going to always see the base, but you should always assume that the base is 10. So, for these examples here, or these basic properties, they should make sense to you, because if the base here is 10, if here the base is 10, then 10 to the 0 power would be 1. 10 to the first power would be 10. And of course, log base 10 of 10, you already know. Oh, sorry. Okay, sorry about that. You already know that those would cancel out because there is a base 10. And if the base is 10, these two would cancel out. And then 10 to the power of log base 10 would cancel out as well. And your answer should be just x, if x is positive, of course. So I gave you a couple examples here. If you are being asked to solve log of 10,000, essentially you'd need to enter, you would have to think 10 to what power? 10 to what power would give you 10,000? And the answer there would be 4, because 10 to the 4th power would be 10 times 10 times 10 times 10, which should give you 10,000. So in this case, the answer would be just 4. Okay? For the second example, if you remember the properties we talked about, the base for a common log here is a 10. So this will cancel out, and their answer will just be 3. Okay? All right, so if we are moving on to the next one, just get to the select 2 here.
Can I help you?
And moving on. Okay, so now if you're looking at graphs of natural log functions, so you already know what you should know what e to the x power is, because e to the x power is an exponential growth function. So you have it listed right here. This is e to the x, exponential growth. The inverse of that would be what we call natural logarithm, which is you can write as ln, okay? And so essentially, the inverse of e to the x would be natural log of x, and these properties here would apply. All right? So you need to know that natural base e and natural log are inverses. These are the properties that you need to apply, which are very similar to common logs. So if you're asked to do this example here, e to the natural log 4, the e and the natural log would cancel out. Your answer would be just 4. Okay? For the next example that I gave you, if you have natural log 1 over e to the third, this could be rewritten as natural log e to the negative 3. You should remember properties of exponents. You should know that e to the negative 3 is the same as 1 over e to the positive 3 power, which means now you can cancel this out and your answer would be just negative 3. Okay? For this one, let's erase this, erase this.
Can I erase?
1 second. Let's draw. Okay, now let's move on to the next one. So in this particular example here, there's nothing I can really cancel out. So in this case, you would need a calculator. So if I use a calculator, if I just evaluate natural log 9. Oh.
No, you don't have any internet right now? Are you serious?
1 second. All right.
I'll tell them the password.
Okay, so natural log 9 is about 2.197. So if I go back to this, 2.197, my answer here then should be 2.197, negative 2.197. Okay, so that would be just a calculator problem.
I have no idea what you're saying.
All right, then the last skill you need to have is with regards to graphs. Okay, so you can have log growth and or log decay, just like with the exponential growth and decay. The same applies for logarithms. So here you have your characteristics, the domain. There are going to be no negatives. And for any number to the 0 power is 1. So that's what the graph is going to look like. And the end behavior is here. There are no extrema. Asymptotes are just going to be the y-axis. This is pretty self-explanatory. It's continuous, no holes, asymptotes, jumps. So if you have those two parent functions, then you should be able to compare this. Pretty much the basic rules that we had before apply. So for instance, if you're being asked to describe this function over here, letter A, you should see that there is going to be a horizontal translation there. So it's going to be translated 4 units to the left. Remember, the sign is always the opposite. And then down here, you have the actual graph. The blue one is just log of x. The red one is the one with the transformation. For letter B, there's a negative in front of log x. So it's going to be a reflection, and it's going to be shifted 5 units down. So this is over here. You have the parent function, which is log x, and then the red function, which is a transformation. And then over here, 3 log x plus 2. You should be able to see that it's going to be expanded vertically because of the 3, and it's going to be shifted horizontally 2 units to the right.
Did you write all of this?
Sorry, to the left, because, yeah, you have to change the sign. So, and that is over here.
Did you write all of this?
I think that's it. Yeah. So let me know if you have any questions. You can reach out to me on Google Classroom or you can email me. Thanks so much.